Our next unit will be current electricity. This screencast will serve as our introduction to current electricity. Current electricity is simply when electric charge is flowing through a conductor. Current is the rate at which electric charge flows through a conductor. It is the amount of charge that flows through a conductor divided by the time. Current is measured in coulombs per second, which is known as an ampere. Due to early misconceptions, current has always been defined as the flow of positive charge. In circuitry, the current is really flow of electrons which are negative. Therefore, when we talk about the direction that current is flowing, it is always opposite the direction of electron flow. The graphic shows the conventional current flow from a battery to a light bulb, leaving the positive terminal and coming back to the negative terminal. And then to the right shows that actual electron current flow from the minus terminal back to the positive. Drift velocity is the mean speed of the electrons flowing through a wire. It is a very low number. Electrons in a circuit typically move through the circuit at a net speed of about 1 meter per hour, but they do not flow in a straight line, as you can see from the picture below. The exact speed depends on several factors, and that's not important for this course. The figure just added shows the drift velocity in a microscopic view of the drift velocity in a copper wire. When you hear about current, you'll hear about either direct current or alternating current. DC, or direct current, is often created by batteries and can also be made by direct current generators. In direct current, the current always flows in the same direction. The conventional current flows from the positive terminal of the battery through the circuit to the negative terminal. Therefore, the electrons are going from the negative to the positive. So in the simple circuit that is detailed below, the conventional current will be flowing from that positive terminal through the circuit to light up the light bulb and returning back to the battery in the negative terminal. Alternating current, or AC, is produced by most generators and is a type of electricity that you get from the outlets in your home. Alternating current switches direction at regular intervals, and in the United States the frequency is 60 Hertz, which means it goes right and left 60 times every second. The figure below shows a graph for alternating current and also one for direct current. Resistance is the opposition to flow of electrons. It's measured in ohms. Insulators have a very high resistance, conductors a very low resistance, semiconductors a medium resistance, and superconductors will have zero resistance at their critical temperature. This temperature is typically close to absolute zero. On Monday we'll be doing a lab activity to try to calculate resistance and see what properties resistance depends upon. Ohm's law shows the relationship between the voltage across a device, the resistance of the device, and the current that will flow through it. The voltage or potential difference across a device is what causes the charge to move through it. The resistance of the device impedes charge from flowing through it. Therefore, the higher the voltage, the higher the current. But the higher the resistance, the lower the current, leading to that equation I equals V over R. You'll often see that equation also showing up as V equals I times R. The electrical outlets in your home provide a voltage of 120 volts. Things powered by batteries usually have a voltage that is a multiple of 1.5 volts, depending on the number of batteries they use. AAA, AA, C, and D batteries are all 1.5 volts. So if you have a flashlight that has 4 D batteries, that flashlight has a voltage of 6 volts. Electric power is the rate of conversion of electrical energy to other forms of energy, or the rate at which charge carriers do work. Electric power for any device or circuit can always be found by multiplying the voltage across a device and the current that runs through it. Remember that 1 volt equals 1 joule per coulomb, 1 amp equals 1 coulomb per second. So by multiplying 1 ampere by 1 volt, we get that 1 joule per second, which is 1 watt. So again, power equals current times voltage. If we use the equation from Ohm's law, V equals IR, and substitute that in for V into the power equation, you can see that power equals the current squared times the resistance. If we rearrange that equation, substitute it in to the power equation, you can also calculate power by being the voltage squared over the resistance. So what's the electric company really selling you? Electric companies charge for the amount of energy used. Energy can be calculated by multiplying the power of a device by the time that device is used. The standard unit of energy is the joule, but electric companies charge by the kilowatt hour. So let's see how many joules there are in 1 kilowatt hour. Take your 1 kilowatt hour, multiply by 1,000 watts per kilowatt, multiply by 3,600 seconds in 1 hour, and you get 3.6 times 10 to the 6 joules, or 3.6 megajoules in 1 kilowatt hour. Now let's look at what you should do the next time someone complains about you leaving your light on at home while you're at school. So if you have one light in your room and it's a 60-watt bulb, you leave it on for half the day, and your electric company charges you 10.372 cents per kilowatt hour. So first we calculate the energy that bulb used throughout the day. And that's 60 watts times 0.5 days times 1 kilowatt divided by 1,000 watts times 24 hours in a day. So that bulb to light your room that no one was inside of used 0.72 kilowatt hours. And to figure out the cost, we take those 0.72 kilowatt hours, multiply them by that 10.372 cents per kilowatt hour, and you wasted 8 cents while you were at school today, leaving the light on in your room. So you can give the person that was complaining a dime and ask him to keep the change, or my recommendation would be to say, I'm sorry, and I'll try to do better tomorrow. Well, that's it for the screencast. I hope you guys enjoyed it. You can use it to fill out the Google form, refer back, and I look forward to seeing everybody on Monday, and we'll be investigating resistance. Thanks, and have a great weekend.